Good morning, Year 5s. I hope you had an absolutely wonderful day yesterday, enjoying the sun in some way or another, whether it was in your garden or potentially even going out, as we're allowed to do now. But it was lovely. This is Thursday's maths video, so we've been looking at mixed fractions, improper fractions, equivalent fractions. So there's a couple of challenges for today, just to get you thinking. So I'll have a look at the do-nows first. So, converting metres to kilometres, we know there's 1,000 metres in a kilometre. We've got 5,000 there, so that must be 5 kilometres. And then the 601. And then 0.67 kilometres, how many metres? Well, again, we know there's 1,000. So, 1, 2, I'll do it here. Don't forget, you've got infinite zeros either side of your number. 1, 2, 3. So it's 670 metres. Okay, remember it says 67, but it's not 67 metres because you've got zeros afterwards. But because there's no other numbers there, it's not a placeholder. You don't need to see the 0. Okay, if there was a 1 there, then you would need it. 12% as a fraction. You could simply just go 12 hundredths. You could look at that now though, and you could simplify that. You could go 6 50ths. You could just halve both numbers. You could start giving me 2. 112%, well that's 1 whole, 0.12, and 3/8. An equivalent fraction, something 24ths. Well, let's have a look what we've got here. 8, 16, 24. I've times that by 3. So you've got to times the top by 3. 3, 6, 9. 9 24ths. Lovely. I have 4 vertices and 6 edges. What am I? Hopefully you've got this right. It is a triangular based pyramid. So you've got your triangle base. Oh, I'm not going to be able to do this. Oh dear, no. So your 4 vertices, you've got your 3 on the base and 1 at the top. And then your 4 edges, you've got 1, 2, 3 for the triangle, and then 1 coming up from each corner, from each vertex. What is this net? You should be able to work that out and notice that is a cone. The last one's, what does percentage mean? Percentage is per cent, so per 100. So out of 100. So whatever amount it is, if it was divided by 100, what would it look like? Out of 100 people, out of 100 things. How many turns is 270 degrees? Well, we know that 360 is 1 full one, and that's gone past that. So we know that 90. Well, we know 360 is full. Okay. So we'll start there. We know that that's 90. We know that that's 180. So what's that and that? 9, if you take the zeros off, 9, 18. Oh, 27, 270. So how many turns is 270? It's 3/4 of a turn. A turn is 1 full rotation, okay? So the answer is it's 3/4 of a turn, okay? 1, 2, 3. So I understand if you didn't quite get that, but maybe you knew how much 270 degrees was. How many degrees in 2 full turns? We've just said 1 full turn is 360. So what's 2 360s? Just quickly check. 0. Just add them together. 720. So 720 degrees is 2 turns. Lovely. Right. On to the challenges for the day. Now they're all a little bit. You know, we had a lot of calculations yesterday that was just drilling in the skill. So we're going to have a little play with some worded problems today. So Ryan has these numbers. He's got a 9, a 3, a 15, a 12, a 4. He wants to use He wants to use 2 cards to make an improper fraction that is as close to 4 1/3 as possible. What fraction should he make? So down here, I've got it written out. he's got these cards. He wants to make an improper fraction, or top-heavy fraction, that is as close to that as possible. Now, my first thing is, hang on, we're talking about two different things here. We've got a mixed fraction, but he wants to get an improper fraction. Let's make it an improper fraction. So, we know it's going to have a denominator of a 3. 4 times 3 is 12. Add 1 is 13. Right, boom. That's easy to work with, isn't it? Now what we've got to do is make an improper fraction that's as close to that as possible. Oh, happy days. We've got a third. And, well, 15 is closer than 10, isn't it? Boom, there's your answer, 15 thirds. It's just testing, spotting when to convert it is key. Alright? Just with anything else, it's like I said yesterday, it's just like your measurements. If you're in centimetres, metres and millimetres, pick one. And it'll make everything easier. Okay? The next part, he wants to make an improper fraction with the cards to get something as close to 4. So the whole amount, 4. So remember, one whole thing is where the numerator and denominator are the same. So 1 would be, 2 halves, 3 thirds, 4 quarters. So we need that with 4. Remember, if improper fraction, if this was then 2, it'd be 4 halves, 6 thirds, 8 quarters. Because you've got 2. You've got double the amount of everything. So it's still in halves, but you've now got 4 of them. Just like yesterday. So we need something that's going to be 4. So you've got to look in here, and you kind of got to use your times tables here. You can't have 10 as the denominator, because you've not got anything near 40. Because 10 times 4 is 40. You've got no number that big. Same with 15. Actually, the same with 9. 9 times 4, 36. You've got no numbers that you can use as a numerator there. I think we're looking at the 3 or the 4 here. So, if we just put a line to there, we're trying to make 4. If we use the 4 as the denominator, or let's have the 3 as well, just to test them out. If you use the 4, well, 9/4, that'd only be 2, wouldn't it? Because you've got 8. 2 4s are 8, and 1 extra. So you can't use, it can't be the 9. 3 is only 3 quarters, that's not a whole thing. 15 quarters. Now that's very close to 4, isn't it? 4 times 4 is 16. 15 is only 1 off. 3. Well, 3 times 3 is 9. That's only 3, but it's close. So I'll put my finger on that one. What about 15 for that one? That's 5 times 3. So that would make 3, but that would be 5. Both equally away from 4 as each other. 10 is a little closer, because it'd be 3 and a little bit. It'd be 3 and 1, wouldn't it? So you'd also use the 15 there. But like we say, that's 5. So your answer is 15 quarters. Because it's only 1 quarter away from a whole 4. Right, the next one. This is a tasty one, and it's the challenges as well. So it might be that you don't choose to do all of these. You might just have a look at some of them. Maybe have a look at that challenge. But have a read of them and try and do at least one of them. But I'm going to have a quick chat about them. So this challenge here. Remember, we've done. It looks a little bit like algebra, doesn't it? Letters replacing numbers. So, like our formulas, so 2L is 2 length. B is double the value of A. So whatever B is, it's double A. C can be whatever makes sense then. Can you find the possibilities? This is all about logic. This doesn't require any fraction skills whatsoever until you've worked out how to do the A and B bit. Okay? So, whenever you get a question that says find all possibilities, start at 1. Okay, so B is double the value of A. Well, my first one then. If A is 1, B is going to be 2. There you go. Which makes C, and then you just solve it. So 8, 9, which makes C 10. You can go again. Right, okay. Well, if now let's make A 2. B is always the double. So that's now 4. What's this one going to be? 8 times 2 is 16, add 4 is 20. C is now 20. It says find all possibilities. There are many, many possibilities. Another one. 1, 2, well, let's do 3 now, shall we? So B is double A. That's now that. 8, 16, 24. Add 6 is now 30. C is now 30. You just need a system. Start at the beginning. Okay? So, find all possibilities. That there are many. Go, just work the way through. Do 5, 6, 7, or 8. See how far you can get. But that one is all about where to start, which is the big thing in 5 and 6 maths. The math, you can do the maths here, but it's where do I start, which is the tricky bit, and it's tricky to teach that as well. It's it's a bit of your logic. The last two. Dave says that 3 3/4 is an equivalent mixed fraction of the improper fraction 45/12. Is he correct? Prove he is correct. So you know it's correct, but prove it. So you got to show it. Well, again, first of all, working with two different things here. Let's make this an improper fraction. So 3 3/4. Well, we know it's going to be quarters at the bottom. 4 times 3, that's 12. Add 3 is 15. So now we're looking at this. Are these equivalent fractions? So remember, whatever you do to the top, you do to the bottom. Can 15 get to 45? Or even simpler, can 4 get to 12? Well, yeah. 4, 8, 12. 3. So if you times that by 3, let's see if that works for 15. 15, 30, 45. Yep, you can times that by 3. So they're equivalent of each other. So Dave is correct. Boom, well done, Dave. Let's see if he's right with this last one. He's also added 3/4 and 3/4. Is all of this correct? All right, now I'm going to talk you through this one. So, we've had do-nows in the past, haven't we, where we've added fractions. And it is quite simply, you add the numerators. The denominators don't change. If you've got 3/4 and 3/4, and you add them together, how many quarters have you got? 1, 2, 3, 4, 5, 6. You've got 6. They are still in quarters though. You haven't suddenly got 8. 8. It's not split into 8 individual things. They're still split into 4, which is why you've got your denominator, but you've got 6 quarters altogether. So this bit here is correct. Let's move on. He then says that that's the same as 1 2/4. Is that correct? Well, 4 fourths equals 1, but he's got 2 extras. So yes, that's correct. He then says that that's the same as 1 1/2. Well, we know any half fraction, the numerator is half the denominator. So well done, Dave. He's got both these questions right today. Like I said at the start, you didn't have to have done all of those challenges. Pick today. It's depending on how you're feeling with your fractions at the moment, alright? This is the only awkward bit for me with the videos. Normally, I can check up on you, see how you're doing, and then give you that little bit of help that some of you might need. But, try and have a look. I know your parents are helping you where they can as well. So just have a look at which ones you can have a crack at today. And well done.